Hello, everybody. In today's lesson, we're going to begin Module 4 of the 6th grade Go Math textbook. We're going to start on page 79. And on our first lesson, it's applying the GCF, or greatest common factor, and the LCM, or least common multiple, to fraction operations. And so basically, we're going to apply and how do we use the GCF and LCM when we have to add, subtract, and multiply fractions. All right, so multiplying fractions. To multiply two fractions, you first multiply the numerators and then multiply the denominators. Okay, it seems simple enough, right? Numerator times numerator, denominator times denominator. The resulting product may need to be written in simplest form. To write a fraction in simplest form, you can divide both the numerator and the denominator by the greatest common factor. Example 1 shows two methods for making sure that the product of two fractions is in simplest form. So example 1, multiply and then write the product in simplest form. So we have 1/3 times 3/5. So we can rewrite that as the numerators on top, 1 times 3, over the denominators, 3 times 5. And we'd get a total of 3/15. Well, if we found the greatest common factor, well, we know that the only factors of 3 are 1 and 3. And 15 is 1, 3, 5, 15. So we would divide the numerator and denominator by a common factor of 3, and it would simplify to 1/5. Okay, so that's one method. So to multiply and then simplify. But actually, the method I actually prefer is which we'll discuss in part B. 6/7 times 2/3. Again, rewrite it as the numerators on top, 6 times 2, over 7 times 3. Then look at the factors that we're multiplying. You'll see that 3 and 6 has a greatest common factor of 3. So why don't I simplify before I even start multiplying? So if 3 divided by 3 is 1, and 6 divided by 3 is 2. Now I have 2 times 2 over 7 times 1. 2 times 2 is 4, and 7 times 1 is 7. So I've already simplified. Okay, the answer is 4/7. All right, let's look at page 80. All right, so let's practice some. So we have 1/6 times 3/5. All right, so again, let's rewrite that so that we have the numerators on top together and the denominators. Now let's see if we can simplify before we start. Well, 1's as there's only one factor of 1, so that's not going to help any. 5 is not a factor of 3 or 1, so there's nothing to do there. But 3 is a factor of 6, so let's reduce or simplify. 3 divided by 3 is 1, and 6 divided by 3 is 2. Now let's multiply straight across. We have 1 times 1 in the numerators, and we have 2 times 5 in the denominators. So we have 1/10. So we can write 1/10 as the answer for number 1. Number 2, we have 3/4 times 7/9. Okay, so that's our problem. Let's rewrite it. So we have 3 times 7 together on the top. Those are our numerators, times the denominators, 4 times 9. Now, when you look at that, are there any common factors? Well, we know 7's a prime number. So 7's not a factor of 9, 7's not a factor of 4. So we can't simplify the 7. But the 3, that is a common factor. 3 is a common factor of 9. So let's divide 3 by 3 and 9 by 3. So now we have 1 times 7 over 4 times 3. 1 times 7, 7, and 4 times 3 12. So 2 is 7/12. Okay, 3. 3/7 times 2/3. All right, so I'm going to rewrite them so that the numerators are together on the top. And I quickly see that the 3's are in common, so we might as well just divide both of those by 3. 2 is not a factor of 7, so that's all we can simplify. So now we're left with 1 times 2 and 7 times 1. 1 times 2 is 2. 7 times 1 is 7. So 2/7. Right, number 4. 4/5 times 2/7. 4/5 times 2/7. Okay, all I've done is rewrite it so that the numerators are being multiplied together on the top in the numerator, and 5 times 7 in the denominator. Well, 2 is not a factor of 5 or 7, so that we can't reduce there. 4 is not a factor of 5, nor is it a factor of 7, so we can't simplify this one at all to start. So 4 times 2 is 8, and 7 times 5 is 35. Okay, well, the only factors of 8, just to confirm, are 1, 2, 4, and 8, right? Well, the only common factor that 8 has in common with 35 is 1. So it's already as in simplest form, 8/35. Number 5, 7/10 times 8/21. All right. Here I know that one of the factors of 8 is 2. So, and I know a factor of 10 is 2. So let's divide 8 by 2, and that gives us 4. And let's divide 10 by 2, which is 5. All right. Now, how about 7 and 21? We know 7's prime. It's not a factor of 5. Is it a factor of 21? Sure, right? 7 times 3. So let's reduce this one by dividing the numerator 7 by 7 and the 21 by 7 to get 3. So now we have 1 times 4 in the numerator, and we have 5 times 3 in the denominator. 1 times 4 is 4, and 5 times 3 is 15. Okay, so that's in simplest form. The only factors of 4 are 1, 2, 4. 2 and 4 are not factors of 15. So 5 is 4/15. And number 6, 6/7 times 1/6. Okay, so as you rewrite that, we're going to put 6 times 1 in the numerator and 7 times 6 in the denominator. What do you notice? You notice that the 6's would be in common. So we're going to divide the numerator by 6 and the denominator by 6. So that leaves us 1 times 1 and 7 times 1. So 1/7. All right, so number 6, 1/7. All right, let's move on to example 2. Multiplying fractions in whole numbers. So to multiply a fraction by a whole number, you can rewrite the whole number as a fraction over 1, right? So 26, that's a whole number. I can rewrite it as a fraction as 26 over 1. And then multiply the two fractions. And remember to use the GCF, or greatest common factor, to write the product in simplest form. Okay. So example 2. A class has 18 students. The teacher asks how many students in the class have pets and finds 5/9 of the students have pets. How many students have pets? So we can estimate the product, multiply the whole number by the nearest benchmark fraction. So 5/9, that's close to 1/2, right? If it was 5/10, I could simplify that to 1/2. So half of 18 is 9. All right, so that's our estimate. We should have an answer close to 9. So multiply 5/9 times 18. Rewrite 18 as 18 over 1, and then rewrite it so we have 5 times 18 in the numerator and 9 times 1 in the denominator. Well, you notice that 9 is a factor of 18. So divide 9 by 9 and you get 1. Divide 18 by 9, you get 2. So we're going to rewrite what's left. We have 5 times 2 in the numerator and we have 1 times 1 in the denominator. 5 times 2 is 10. 10 over 1 simplifies to 10. Okay. All right, so now let's practice. Number 7. Is the product of a fraction less than 1 and a whole number greater than or less than a whole number? Well, let's just look at it this way. 26 times 1. That's a whole number times 1 whole, right? And we get 26. What if we multiplied the whole number by a fraction less than 1? Well, half of 26 is 13. So, is the product of a fraction less than 1 and a whole number greater than or less than the whole number? It's less than. Okay, so if the fraction is less than 1, the product is always less than the whole number. And we saw that in our example. Okay, 1/2 is clearly less than 1. If 26 times 1 is the whole number, if you multiply by something that's less than that whole number, you got to get something smaller than the whole number. All right, so let's practice this. 5/8 times 24. Well, we can rewrite 5/8 times 24 as 24 over 1. So we can rewrite that as 5/8 times 24 over 1, which would be 5 times 24 in the numerator and 8 times 1 in the denominator. Well, 5 is prime, and it's not a factor of 8. 1's prime. No, 1's not prime. 1's neither prime nor composite because there's only one factor of 1. So that doesn't help us any, right? But 8 and 24 does. 8 divided by 8 is 1, and 24 divided by 8 is 3. So rewrite what we have. Now we have 5 times 3 in the numerator, which is 15, and we have 1 times 1 in the denominator. 15 divided by 1 simplifies to 15. Okay, number 9, 3/5 of 20. I can rewrite 3/5 times 20 as 3/5 times 20 over 1. Sorry about that. Having problems focusing. So I'm going to rewrite that as 3 times 20 over 5 times 1. All right, well, the 3 is not going to help me any with the denominator, but 5 in the denominator is a factor of 20. So divide 5 by 5 and divide 20 by 5. 20 divided by 5 is 4. So we have 3 times 4 in the numerator times 1 times 1. So that would be 12 over 1, or 12. Okay, number 10. 1/3 of 8. 1/3 of 8. So we know we can rewrite 1/3 times 8 as 1/3 times 8 over 1. Put the numerator 1 and times 8 together, and put the denominator 3 times 1 together. Well, 3 is not a factor of 8, so multiply your numerators and denominators. Now let's simplify. Well, how many 3's can we take from 8? 2, right? Okay, so 3 times 2 is 6 with a remainder of 2. So 2 and 2/3. Number 11, 1/4 times 14. So we know we can rewrite 14 as 14 over 1. So now we have 1 times 14 in the numerator and 4 times 1 in the denominator. Well, 14 and 4 are both even numbers, right? So we know that 2 is a factor of both of those numbers. 4 divided by 2 is 2. 14 divided by 2 is 7. So now we have 1 times 7 over 2 times 1. 1 times 7 is 7. 2 times 1 is 2. Okay, let's simplify that. 7 divided by 2. We can take 3 2's from 7 with a remainder of 1. So 3 and 1/2. Number 12, 3 and 7/10 times 7, which we can rewrite as 7 over 1. All right, so again, this is number 12. So I have a mixed number here, and I want to go ahead and change that into a fraction greater than 1. So we know that in 3 wholes, in this example, would be 3 sets of 10/10. So we go 3 times 10, 30, plus the extra 7/10 is 37/10 times 7 over 1. Okay, well, 7's not a factor of 10, so that doesn't help. 37, that's a prime number, so that doesn't help. So we just have to multiply across. Okay, so it's 37 times 7. Well, 7 times 7 is 49. Regroup, that's 4 10s and 9 1s. 7 times 3 10s is 21 10s, plus 4 more 10s is 25. So 259 over 10. Okay, let's simplify that now. 259 divided by 10. We can take 2 10s from 25. And we have 5 left over. And we're going to bring down the 9 1s. I can take 5 10s from 59. And I'd have a remainder of 9. So 25 and 9/10. Okay, does that make sense? Is that reasonable? Well, if we go 7 times 3, that's 21. If we round 7/10 to the next whole number, we would have 4 wholes here. 4 times 7 is 28. So our answer has to be between 21 and 28, which it is. Okay. All right, 13. 2 3/10 times 10 over 1. So we're going to rewrite 10 as 10 over 1. Okay, again, we are going to go ahead and change this to a fraction greater than 1. 2 sets of 10/10 is 20, plus 3 more is 23/10 times 10 over 1. All right, well, the 10s are in common, so let's simplify those by dividing by 10. And now we're left with 23 over 1, or 23. Is that a reasonable answer? Well, 10 times 2 is 20. Okay, so 23 is reasonable. All right, adding and subtracting fractions. All right, you've learned that to add and subtract 2 fractions, you can rewrite the fractions so that they have the same denominator. Well, to find a common denominator, we're going to use the least common multiple of the denominators of the fractions to rewrite the fractions. So example 3. For instance, if we want to add 8/15 plus 1/6, well, we're going to rewrite the fractions as equivalent fractions, and we're going to use the least common multiple of the denominators. The least common multiple of 15 and 6 is 30. You'll remember that to find the least common multiple, we're just going to list the multiples of the numbers. 30, okay? So 6, 12, 18, 24, 30. And I recognize that if I double 15, that's 30. So again, the least common multiple is 30. So how do we turn 8/15 into 30ths? Well, we'd have to multiply the 8 by 2 to get 16 and multiply the 15ths by 2 to get 30ths. The 1/6, to turn it into 30ths, we'd have to multiply by 5. So if I multiply the denominator by 5, I multiply the numerator by 5, and we get 5/30ths. Well, now we just add the fraction. 16 plus 5 is 21 over 30. See if there's a common factor. There is, right? One of the factors of 21 is 3. Well, and I know 3 is also a factor of 30. 3 times 10. So we're going to divide 21/30ths by 3 over 3, and we come up with an answer of 7/10. All right, 14. Can you use the least common multiple of the denominators of the fractions to rewrite the difference 8/15 minus 1/6? Yeah, of course we can. So we have 16/30ths minus 5/30ths. So 16/30ths minus 5/30ths is 11/30ths. Well, I know 11 is a prime number, and nothing times 11 would give me 30. So that's the answer, 11/30ths. Let's move on to page 82. All right, we're going to add or subtract, and we're going to write each sum or difference in simplest form. All right, 15. 5/14 plus 1/6. 5/14 plus 1/6. So I need to find a common multiple of 6 and 14. 6, 12, 18, 24, 30, 36, 42. I think 42 is a multiple of 14. Let's see. 14 plus 14 is 28. And 28 plus 14 is 42. So yes, the least common multiple of those two fractions is 42. So 5/14 times 3 over 3 will give me 15/42. 1/6 times 1, 2, 3, 4, 5, 6, 7 over 7 will give me 7/42. Okay, so 15/42 plus 7/42. 15 and 7 is 22 over 42. I know a common factor is 2. 22 divided by 2 is 11. And 42 divided by 2 is 21. 11 is a prime number. It is not a factor of 21. So 11/21. Okay, 16. 5/12 minus 3/20. 5/12 minus 3/20. So let's find the least common multiple. Now I'm going to start with the 12 because I know that the multiples of 20 will have to end in a 0. So I'm going to try to find a number that's a multiple of 12 that ends in a 0. So 12, 24, 36, 48, 60. Okay, so 12 times 5, right, is 60. So 20, 40, 60. So we're going to turn 5/12 and 3/20 into 60ths. So 5/12 times 5 over 5 will give me 25/60 minus 3/20. I'm going to multiply 3/20 by 3 over 3 to change it into 60ths. All right, so 25/60 minus 9/60. 25 take away 9 is 16/60. I know 2 as at least one of the factors of 16/30. 16 divided by 2 is 8. 60 divided by 2 is 30. See, so I didn't divide by the greatest common factor, right? So let's try again. Divide by 2. 8 divided by 2 is 4, and 30 divided by 2 is 15. So 4/15 is the simplest form of 16/60. So what I should have done to do that in one step is divide by 4. 16 divided by 4 is 4. 60 divided by 4 is 15. So 4/15. 17. 5/12 minus 3/8. Okay, so we have 5/12 and 8. I'm going to stop there at 24 because I know 12 can become 24. So 5/12 I'd multiply by 2 over 2, and I'd get 10/24. 3/8 I'd multiply by 3 over 3, and I'd get 9/24. Okay, since that is a subtraction problem, 10/24 take away 9/24 leaves me 1/24. Okay, number 18. 1 3/10 plus 1/4. All right, I could turn this into a fraction greater than 1, but remember 1 3/10 can be written as 1 plus 3/10, right? So 1 plus 3/10 plus 1/4. So let's just work with the 3/10 and the 1/4. And I know that 4 can become 20 and 10 can become 20. So 3/10 times 2 over 2 will give me 6/20. So 1 3/10 is the same as 1 6/20. And 1 times 1/4 times 5 over 5 would be 5 twentieths. So 6 plus 5 twentieths is 11 twentieths, and 1 plus nothing is 1. So we get 1 and 11 twentieths. Okay, number 19. 2/3 plus 6 and 1/5. Okay, again, 6 and 1/5 can be rewritten as 6 plus 1/5. So let's just find a common denominator of 2/3 and 1/5. Okay, in this case, 3 and 5 are both prime. So I'm just going to multiply 2/3 by 5 over 5, and I'll multiply 1/5 by 3 over 3. In other words, I know that if I multiply the thirds and the fifths, I'd get a common denominator of 15ths. So 2/3 is the same as 10/15, and 1/5 is the same as 3/15. Okay, so we have 10/15 plus 6 and 3/15. So 10/15 plus 3 is 13/15. 6 plus nothing is 6. So 6 and 13/15. Number 20. 3 1/6 minus 1/7. Okay, so I'm going to rewrite this one so we have it stacked like this. 3 1/6 minus 1/7. 7's a prime number, so I know that to find a common denominator, I can multiply 7 times 6. I don't know why he's having problems focusing today. All right, so 6 times 7 is 42. So I'm going to multiply 1/6 by 7 over 7 and multiply 1/7 by 6 over 6. All right, so all right, again, I apologize for that. So 7 40-seconds, take away 6 40-seconds is 1 40-seconds. 3 take away nothing is 3. So 3 and 1 40-seconds. All right, 21. Guided practice, starting on page 82. All right, number 1. 1/2 times 5/8. Okay, I know that I can rewrite that as 1 times 5 over 2 times 8. There's no common factors in the numerator or denominator, so I'm just going to multiply across and get 5/16. Okay, number 2. I can rewrite it as 3 times 5 over 5 times 9. I know that a common factor of 5 is 5, so divide both of the 5's by 5. And I also know that 3 is a factor of 9, so divide 3 by 3, which gives me 1, and 9 divided by 3 gives me 3. So 1 times 1 is 1, 3 times 1 is 3. So that's in simplest form. Okay, number 3, 3/8 times 2/5. Okay, well, 2 is a factor of 8. So 8 divided by 2 is 4. All right, so now we're left with 3 times 1, 3, and 4 times 5, 20. 3/20. 2 3/8 times 16. So I know that there's 2 sets of 8/8 or 16/8 plus 3 more is 19/8 times 16 over 1. So 19 times 16 over 8 times 1. 8's a factor of 8, and 16 divided by 8 is 2. So now we're left with 19 times 2, 38, and 1 times 1 is 1. So our answer is 38. So number 4 is 38. Number 5, 1 4/5. That means we have one set of 5/5 plus 4/5 is 9/5 times 5/12. Okay, greatest common factor of 5 and 5 is 5. So 5 divided by 5 is 1. 5 divided by 5 is 1. Common factor of 9 and 12. That's 3, right? 9 divided by 3 is 3. 12 divided by 3 is 4. So we have 3 times 1, just 3. 1 times 4, 4. So 3/4. Number 6, we have 1 and 2/10. That means we have one set of 10/10. So 10 times 1 is 10, plus 2 more is 12/10. Rewrite 5 as 5 over 1. All right, well, I know a common factor of 5 and 10 is 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Okay, but I can even simplify that further before multiplying because 2 is a factor of 12. So 2 divided by 2 is 1, and 12 divided by 2 is 6. So we have 6 times 1 is 6, over 1 times 1 is 1. So our answer is 6 for number 6. Okay, number 7. We want to find out the answer to 1/4 of 12 water bottles. Okay, well, 1/4 of 12. Well, I'm going to rewrite that as 1/4 times 12 over 1. Okay, well, a common factor of 4 and 12 is 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So 3 bottles. 1/4 of 12 is 3. Number 8, 2/3 of 24. 2/3 of 24. Rewrite that as 2/3 times 24 over 1. Which is the same thing as saying 2 times 24 over 3 times 1. 3 is a factor of 24. So divide 3 by 3, which gives us 1. Okay, so we're simplifying thirds to 1. And 24 divided by 3 is 8. 8 times 2 is 16. 16 over 1 is 16. Okay, 3/5 of $40. Rewrite 40 as 40 over 1. All right, so 3 times 40 over 5 times 1. 5 is a factor of 40. 5 divided by 5 is 1. 40 divided by 5 is 8. 3 times 8 is 24. 1 times 1 is 1. Simplifies to 24. So 3/5 of a $40 restaurant bill is $24. 5/6 of 18 pencils. So we're going to write 5/6 times 18. We'll rewrite that as 5 6 times 18 over 1. Rewrite that so we're multiplying the numerators over the denominators. 6 is a factor of 18. So 6 divided by 6 is 1. 18 divided by 6 is 3. 5 times 3 is 15. 1 times 1 is 1. So 15 firsts is 15. All right, number 11. Add or subtract and write each sum or difference in simplest form. All right, so 3/8 plus 5/24. 3/8 plus 5/24. All right, so on this one, I'd look at the 8. Can 8 become 24? Sure, by multiplying by 3 over 3, right? So 3/8 times 3 over 3 plus 5/24. So 3 times 3 is 9. 8 times 3 is 24. So 3/8 is the same as 9/24 plus 5/24. 9 plus 5 is 14 over 24. Well, I know a common factor of 14 and 24 is 2. 14 divided by 2 is 7. And 24 divided by 2 is 12. This is in simplest form because 7 is a prime number and 7 is not a factor of 12. So 7/12. Okay, number 12. 1/20 plus 5/12. Well, we've actually already had a problem in our work today using 20ths and 12ths. We know that 12 can become 60 by multiplying by 5, and we know 20ths can become 60 by multiplying by 3. So let's rewrite these as equivalent fractions. Okay. So 1/20 times 3 over 3 is 3/60. And 5/12 times 5 over 5 is 25/60. Add those together, we get 28/60. I know one of the factors of 28 is 4, and 4 is also a factor of 60. So I'm going to divide both of them by 4. And I come up with an answer of 7/15. Number 13, 9/20 minus 1/4. Okay, I'm going to look at the smaller denominator 4. Can it become 20? Yes, by multiplying by 5, right? So 1/4 times 5/5 would be 5/20. So we have 9/20 minus 5/20. 9 take away 5 is 4/20. Well, those are both even numbers, so I know I can reduce it by at least 2. But 4 is a factor of 20. So let's simplify by using the greatest common factor, 4. So 1/5. Okay, 14. 9/10 minus 3/14. Okay, again, I know that one of the common denominators in this case means that this has to end in a 0 because the multiples of 10 all end in 0. So all we really have to do is find the multiples of 14. So 14, 28, 42, 56, 70. All right, so 9/10 can become 70 by multiplying by 7. That's 63/70. 3/14 can become 70 by multiplying by 5. Okay. 63 minus 15. Well, I can't take 5 from 3, so I'm going to regroup. and I'm left with 48/70. Well, what are the factors of 48? Let's see. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. What are the factors of 70? 1 and 70, 2 and 35, 5 and 14, 7 and 10. So, what are the factors in common? 1s, 2s. That's it, 1 and 2. So let's divide these by 2. 48 divided by 2 is 24. And 70 divided by 2 is 35. So 24/35. (15) 3 3/8 plus 5/12. Okay, when I look at the eighths, okay, I'm going to ignore the 3 because this can be rewritten as 3 plus 3/8 plus 5/12. I know 8 can become 24. 12 can become 24. So let's change the eighths into 24ths. So that would be 3 and 9/24. And 5/12, I'm going to multiply by 2 halves, and I'd get 10/24. Add those together, we have 19/24, 3. So 3 and 19/24. Okay, number 15, it's number 16, I mean. 5 7/10 minus 5/18. Okay, I know that the answer common denominator must end in a 0. So what are multiples of 18 that end in 0? 18, 36, 54, 72, 90. All right, so I'm going to multiply 5/18 by 2, 4, 5, and I get 25/90. I'm going to multiply 7/10 by 9/9, and I get 63/90. Okay, we are subtracting. I can take 25 from 63. 38/90. I know a common factor of 38 and 90 is 2. And 19 is a prime number. 19 is not a factor of 45. Okay, so 5 and 19/45. And 17. How can using the GCF and LCM help you when you add, subtract, and multiply fractions? All right, well, we can use the GCF to simplify fractions. when finding sums or differences, when finding sums, differences, and products. Okay, so that's how GCF would be helpful. It helps us simplify the fractions when we find sums, differences, and products. And we use the least common multiple of the denominators of fractions to add and subtract fractions. Okay, so basically, bottom line, GCF helps us simplify fractions. LCM helps us find a common denominator when we add and subtract fractions. Okay.